Hi, I'm Arnie Gunderson from Fairwinds, and it's been a little more than a week since our last video. The video computer we used had a meltdown, and I'm sorry that kind of set back our production schedule a little bit here. However, I'd like to thank you, those of you who donated. We were able to go out and get a better computer, and hopefully these productions will be up and running again permanently. Thanks again. Today I wanted to talk about the lessons that can be learned worldwide for the operating nuclear reactors that are already done and in use, not under construction. The first and most obvious thing is the containment. Containments were made to contain radioactivity. The vents you hear about and how they failed were an add-on. Back in the 70s and 80s, when these plants were designed, they weren't designed to have a vent. As a matter of fact, the pressurized water reactors around the world don't have a vent even now. So these containment vents were a band-aid fix to a problem that was identified after they were built. Now, the vents have been tested 3 times, at Fukushima 1, Fukushima 2, Fukushima 3, and they failed 3 times. That's a 100% failure rate. That's an indication that this design is seriously flawed, and it can happen here. It can happen in Germany, where they also have this type of reactor, and at the other BWR reactors around the world. So first and foremost, the vent system that's on every boiling water reactor needs to be evaluated to see if it can be made better or it should be eliminated. And if it's eliminated, what should we do about the containment that can't withstand the pressures of an accident? Vents can also cause problems. For instance, here in Vermont, the reactor is designed to be pressurized after an accident to push water into it. Well, if they open the vent and it stays open, they'll lose that pressure and they won't be able to cool the reactor. So we can have a meltdown. That doesn't apply just here. That applies at Dresden, it applies at H.B. Robinson, and other plants. The NRC allowed this to happen. They allowed utilities to take credit for the containment pressure to push the water to the pumps. There's regulations on the book prohibiting that, but the NRC waived those regulations when they increased the power at Dresden and Vermont Yankee, Robinson, and some others. So it's important to remember that vents were designed to prevent a problem, overpressure of the containment, but now they can actually create a problem if, when they're open, they don't close. And if you take a look at Fukushima, it's hard to believe that you can guarantee those valves will close after an accident. Well, I've been on the NRC's case about containment leakage for a long time. At Beaver Valley, there was a hole in the side of the containment. I brought that to their attention several years ago. The full report's on the website. At Fitzpatrick, there was a crack in the side of the containment. I brought that to the NRC's attention last year. And at Millstone, it has the smallest containment for the power output of any of that type of reactor in the world. I brought that to the NRC's attention about 2 years ago, and they actually said for Millstone that they don't have the capability to analyze containments. It's in the notes. Yet, the NRC still assumes that containments will not leak. They've actually said that in an advisory committee to reactor safeguards meeting back in October of last year. So we've got a containment that doesn't contain a regulator who doesn't have the capability to regulate, and an industry with a series of cracks and holes in containments that continues to believe there's zero probability of a containment leak. Well, moving on, I wanted to talk about seismic criteria. That's earthquake resistance. We now know that Fukushima 1 failed because of the earthquake, not the tsunami. It was leaking and in the middle of a meltdown before the tsunami even hit. We also know from another report that's on the website by Siemens that Unit 4's fuel pool cracked from the earthquake, not from the tsunami. Well, what that means is that the codes we use to analyze these plants are flawed. They shouldn't crack, they shouldn't break. This wasn't at Fukushima that big an earthquake. It was out at sea in 9, but by the time it got to Fukushima, they should have been able to ride out that storm, at least the seismic issues of it. Well, what that says is that what we've been relying on in analyzing these plants may not be working. 2 out of the 4 plants developed cracks from an earthquake, and they should have been able to just to get through those. In the U.S. reactors, we've got another reactor down at Crystal River in Florida that developed a 60-foot long crack in the containment when they cut a hole in it to replace a steam generator. Well, what that means is that this was the most analyzed containment in history, and they still never saw that crack coming. Well, they tried to fix it and spent 2 years on the repair, and as they were ready to run again, they found another crack had grown in a different direction. We clearly don't have the seismic code capability to analyze these massive structures. Crystal River proves it here in the States, and Fukushima proves it around the world. A couple other ones that are really obvious are the batteries. There's not enough of them. The longest lived batteries in an American plant are 8 hours, but most are only 4. We could not ride out a loss of power accident like Fukushima. In fact, it would be worse. The other thing is the tidal surge. Now, Fukushima had a tsunami, and they were designed for a 6 or 7 meter tsunami around 20 feet, and in fact the tsunami was 15 meters. At the California plants, San Onofre, they're designed for a 30-foot tsunami. But yet we know there was a 45-foot tsunami in Japan. So we need to take a look at these tidal surges that can wipe out, maybe not the diesels, but the pumps that pump the water to the diesels. On the East Coast, you got Florida and the tidal surge from an earthquake. Sorry, from a hurricane. And what that means is that the hurricane can push an enormous wall of water inland. And for instance, the Turkey Point plants can get inundated by the flood from that tidal surge. We need to look at these events that right now we've said are impossible in light of what proved to be possible at Fukushima. Well, 2 more things. The first is emergency planning. In the United States, we analyze for 10 miles out, and there's really no basis in science for 10 miles. Basically, we didn't know which way the wind was going to blow, so we put a 10-mile circle around the plant. We said everybody's got to be able to get out of here within a couple hours. But Fukushima showed us that the accident continues for weeks, and it goes with a meandering plume deep inland. We are not prepared for an evacuation that would be 50 miles away. Fukushima is already contaminated out beyond 50 miles. There's some plants like the Dresden units in Illinois and the Indian Point units in New York State that have major cities, Chicago and New York, within that zone. We really need to take a look at siting of nuclear plants and real emergency plans in place of the paper plans we have in place. Well, the last thing is multi-unit sites. And Fukushima showed us that if one unit blows up, it can impede your ability to solve a problem on other units. And here we've got, for instance, Palo Verde out in Arizona rather, and they have 3 units on one site, and just 2 weeks ago the NRC gave them a 20-year license extension. Well, how could they possibly have analyzed the results of Fukushima and come to an adequate analysis of a multi-unit site? Well, that's a technical wrap-up. There's one more political issue, and it's Price-Anderson. Price-Anderson is the insurance program that utilities have in place. In the event of an accident, all of the reactors in the country pony up about $100 million apiece, and there's a $10 billion cap on their liability in the event of an accident. Fukushima is going to be around $200 billion. If it happens here, what does that mean? That means that you and I, as taxpayers, shoulder the rest of that. We're on the hook for $190 billion in the event of this. And that's what Price-Anderson is. I think in light of Fukushima, we should evaluate whether or not it's right to give these reactors a free ride on their insurance. Well, that's all for now. Thank you very much.
In the rest of the news, U.S. Navy sailors on board the USS Ronald Reagan were some of the first Americans to respond to the tsunami and nuclear disaster in Fukushima, Japan in 2011. Now they're suing TEPCO, the company in charge of the stricken Fukushima Daiichi nuclear power plant. At least 71 sailors on the USS Ronald Reagan have reported radiation sickness, and they're suing TEPCO, alleging that the company knowingly downplayed the dangers of nuclear radiation at that Fukushima site. Of those 71 sailors, at least half now have some form of cancer, according to the lawyer representing them. And other sailors are dealing with thyroid and reproductive health problems. So did TEPCO knowingly mislead the world about the radioactive dangers at Fukushima immediately following the devastating tsunami? And could this lawsuit be the first of many to come? Joining me now for more on this is Kevin Camps, radioactive waste watchdog at Beyond Nuclear. Kevin, welcome back.
Thanks, Tom.
It's always nice to see you.
Thank you.
So what's the story? I think I've seen absolutely no coverage of this in any American media. So first of all, is it actually real that the soldiers aboard the USS Ronald Reagan off the coast of Japan when Fukushima melted down were exposed to high levels of radiation?
Well, it's a shocking story, and I first learned of it last March 11th, which was the second anniversary of the Fukushima catastrophe beginning in 2011.
So they had kept this buried for 2 years?
Two of the sailors came to a big gathering in New York City to mark the anniversary, and they were suffering health effects from their service on board the Reagan. Turns out that the Reagan was anchored just a mile or two off of the Fukushima Daiichi nuclear power plant during the worst of the radioactivity releases,
right,
which was news to me. I mean, I follow this as closely as I can. 2 years into this thing, I find out that the Reagan was that close to these catastrophic radioactivity releases. So the crew on board that ship, 5,000 plus sailors, were in harm's way for several long days on end. Not warned by TEPCO, not warned by the Japanese government, not warned by the United States government, which had radiation detecting planes flying all over northeastern Japan. So,
well, you would think that an aircraft carrier in this day of dirty bombs and you know that they would have radiation detectors on the ship.
Well, some of the first news that was really disturbing in the first days of Fukushima Daiichi was that the aircraft carrier detected radioactivity on the helicopters coming back, landing on board the flight deck. And so one of the sailors who's now stepped forward in a big way was servicing those helicopters. Another of these sailors that I met in New York, his name is Maurice Ennis. He set off the radiation monitors below deck when he came down from being on the flight deck. So there were lots of indications that there was something seriously wrong, but they stayed in this contamination plume for days on end. So they were getting the radioactive gases, which they were breathing in. They were getting the fallout onto them, so they're being exposed that way. What I didn't realize until this latest news about the relaunch of this lawsuit against Tokyo Electric, even the water that the sailors were drinking was from their desalination system. So they were getting the seawater that was contaminated with radioactivity. It was being desalinated by the ship, and they were drinking it. They were cooking with it. They were showering with it. Wow. But those desalination processes don't take out the radioactivity.
Right, because salt is a fairly large molecule. It's sodium and chloride, and if you've got just an individual atom as opposed to a molecule or a particle, the desalination is not going to take it out. Right?
You need special filters. You can't get tritium out of water, period. Not at industrial scale.
It's smaller.
It is water.
It's helium.
Yeah, it's hydrogen. It's radioactive hydrogen. Yeah. You need special filtering to get out the cesium, to get out the strontium. None of that was taking place. So that ingestion pathway combined with all the others could account for some of these health effects we're seeing.
So what's the, has the government stepped up and done anything? Are they testing the 5,000 soldiers, or is it just these 71 who are sick who are suing? I mean, what's the deal?
Well, the common story I keep hearing from these sailors who are, stepping up and speaking out is they don't even have health care. I'm not sure what's going on, but they're kind of on their own resources. Most have had to leave the service because of debilitating health conditions. So they seem to be in, desperate straits. They're looking for, some funding to help them get the health care that they need.
You know, Senator Sanders is the chairman of the Veterans Committee. Somebody, you should bring that to his attention. I'll try to do so tomorrow. He's going to be on our show. We just have 90 seconds here. I'm wondering what's the, you know, we've heard that Reactor 3 has got steam coming out of it. We were reporting today on our radio show that it's not, you know, it doesn't seem to be an immediate crisis. What is going on?
Well, I think Arnie Gunderson at Fairwinds has explained it well. It's the weather conditions that make the steam visible. But what people need to realize is that we're almost 3 years into this thing. Those releases are happening every day. Those releases atmospherically.
It's just that when it gets cold enough, you see it.
You see the condensation. Yeah. But those releases into the ocean are happening every day. They have been for 3 years. So that is the massive radioactivity release that's going on. Once in a while, it becomes more visible because of atmospheric conditions. That you would see, you know, you see your breath when it's cold outside. Right. So we're seeing this heated water coming out of Unit 3. It's just the tip of the iceberg.
And Unit 4, the one that was listing that had all the rods up at the top, that they were going to start taking those rods out, pulling the cigarettes out of the broken, crushed pack. Yeah. How's that going?
Very little reporting, which is kind of scary, actually. So one would assume that without the reporting that it must be going smoothly, but I'm not sure that that's the case.
Maybe it's not going at all?
We don't know. We hear very little about what's going on.
And the stories about the Japanese mafia hiring homeless guys to clean this site up, is that true?
You know what's incredible? Yeah, it is true. Is this new State Secrets Act is making things even worse, where it was difficult for reporters to get in and cover this stuff in the first place. Now it's against the law.
This is a Japanese State Secrets Act.
That's right.
That's amazing. Kevin Camps, thanks so much for being with us.
Thanks, Tom.
Good to see you.
Workers are about to begin preparing to drain underground tunnels at the disabled Fukushima Daiichi nuclear power plant. This comes before the start of a project to freeze the earth around the openings of the tunnels to block the flow of contaminated water. The tunnels are believed to be one of the sources of radioactive materials that are polluting the groundwater at the facility on a large scale. Workers at Tokyo Electric Power Company plan to block the flow of tainted water between the damaged buildings and the tunnels. The workers will start burying pipes in the ground to carry refrigerants later this month. They plan to start draining the contaminated water from the tunnels in April after the freezing work is completed. TEPCO will also begin testing a plan to freeze soil over a large area. The eventual goal is to surround the reactor buildings and other facilities with walls of ice to prevent fresh groundwater from seeping in beneath the facilities. A large amount of highly radioactive water has accumulated beneath the plant. TEPCO officials will also set up radiation monitoring equipment at various hot spots on the floors of reactor buildings. The readings will be used to support the decontamination work by robots that will follow. Officials say they will also study how to remotely locate and repair holes in the reactor containment vessels. The vessels were broken in a nuclear accident.
Farmers across Japan will soon be joining forces to boost their sales overseas. Trade experts are getting ready to help them market their produce together under a national brand. Officials with the Japan External Trade Organization say foods promoted as regional specialties don't have a strong identity abroad. They say producers in different regions should brand their offerings as Japanese and join hands to promote them. For instance, they want to see cooperation between scallop farmers in the northern prefectures of Aomori and Hokkaido. They plan to help producers operate booths together at food fairs.
Pushing the All Japan brand is the best way to help consumers abroad appreciate what producers have to offer.
Japanese government leaders aim to more than double annual exports of agricultural and marine products by 2020. Launched an investigation on Saturday at a factory of the subsidiary of one of the largest manufacturers of frozen food in Japan for alleged poisoning of its products. Last month, health authorities in Gunma Prefecture near Tokyo found that 7 kinds of meal packs produced by Acli Foods, a subsidiary of Maruha Nichiro Holdings, contained a pesticide called malathion. Maruha Nichiro Holdings has recalled 94 products, including pizza and croquettes. These contained as much as 1.5 million times the allowed limit of the pesticide. Health authorities say it is unlikely that the pesticide was added in the ordinary production process, as it's not used in the factory. Police allege that someone could have intentionally added the poison. They started an on-site investigation at the factory in Gunma Prefecture on Saturday. Police will check details of production flows and question officials and workers. Officials at Acli Foods say the poisoned products were packed in the same room and kept in cold storage in the factory after they were cooked on 3 separate lines. Acli Foods officials say they've also started interviewing the factory's 300 workers to find any irregularity. Expectations are increasing that Japan will play a leading role in the push for nuclear disarmament. Government officials recently made the historic decision to commit Japan to a United Nations statement that opposes the use of nuclear weapons under any circumstances. The UN statement came amid arguments between countries that want a treaty banning atomic weapons and those favoring a more gradual approach that allows for nuclear deterrence. Previously, Japanese government officials had said this no-use policy was incompatible with the country's reliance on the U.S. nuclear umbrella. But an observer on nuclear disarmament notes the country should take the lead on the issue.
Japan, the only country to have suffered atomic bombings, has a crucial role in global nuclear disarmament.
Japan plans to host an international conference in April to discuss nuclear disarmament. The meeting of foreign ministers from countries that do not possess nuclear arms will take place in Hiroshima, the site of a nuclear attack in World War II.
We need to get subscribed and get this unity stronger and beat YouTube at their own game. Okay, that's what this is about. Like I say, go to the remix button, hit the remix button. That way you'll have this video and keep up with this. Otherwise, YouTube's just going to control us, guys, and it's really bad.